Now, after we've done with arithmetic progressions, we have 3 more formulas from geometric progression, and we are going to look at the first one, how to derive the nth term or Tn of a geometric progression. So for geometric progression, when we list out all the terms, to get the second term, we multiply the first term by the common ratio, r. Okay, T1 times r, you get T2, T2 times r, you get T3. Okay, so for T1 we let this to be A, and then for T2, we know that T2 is T1 times R, and T1 can be replaced by A, so it would be A times R. Then for the third term, we take the second term, we multiply by R, and we know that the second term is actually A times R, so again we are going to replace T2 by A times R. Okay, T2 replaced by A times R times the R here, and we will get AR squared. And then we repeat the same procedure for the third time. So T4 equals to T3 times R, and T3 is replaced with AR squared times R. So hence T4 equals to AR cubed. Again, we only look at the terms in terms of A and R, so I'm going to erase this. To represent Tn, first there will be an A, so actually this is AR, okay? There is an A here, A, so going to copy. Then for the R, we have a R to the power of 1, R to the power of 2, R to the power of 3, hence here will be R to the power of 0. So when you have running numbers, we always represent this by using n, so R to the power of n, but we found that the value here is 1 less than this. This is always 1 less than this, which we already used an n here, so this will have to be n minus 1. Now for some of nth terms, first we want to try to understand or try to list down the terms T1, T2, T3, T4 in terms of A and R by using the formula. Okay, Tn is equals to ARn minus 1. So the first term T1 is A. Okay, T2 can be replaced by, if this is T2, it will be AR2 minus 1, which is AR. AR n minus 2, this is the second last term, and the last term will be AR n minus 1. So if you want to find the sum of the n terms, you will have to add all this up. You have to find the total, which means you have to take A plus AR plus, then we label this as equation number 1. For the next thing, we are going to multiply equation 1 by R. Multiply equation 1 by R means all the terms here, we have to multiply them by R. So if you multiply Sn by R, you get R Sn. A multiplied by R, you get AR. Here, if you multiply by R, means this is plus 1, you get AR to the power of n minus 1. And the last one is AR n minus 1. If multiplied by R means plus 1, negative 1 plus 1, you get 0, which is this. Label this as equation number 2. What will happen if we take equation 1 minus equation 2? So equation 1 minus equation 2 means this minus this. You get Sn minus R Sn. Okay. Then for the right hand side, you see that if 1 minus 2, if you take this, we minus this, you cancel it off, becomes 0. If you take this minus this, they are cancelled. Okay, so then the third term, the fourth term here will minus by the third term, because since they are the same, becomes 0. And so we'll cancel off all this until we have this and this left. Okay, because this is cancelled by this as well. So you have these two terms left. You take A minus AR to the power of n. So in order to get this form, we need the Sn here. So we factorize Sn. So what is left inside the bracket here after we do the factorization, we get 1 minus r. Likewise here, we are going to factorize out the a times 1 minus r to the power of n. And we are going to move this here. So it becomes Sn equals to a 1 minus r to the power of n over 1 minus r. And you can see that this is this part. How about the second one? So the second one can be done similarly, but we are, instead of taking 1 minus 2, we are taking 2 minus 1. So let me show you. If we take 2 minus 1, okay, means the term below here minus subtracted by the term up here, so it becomes rsn minus sn. So likewise, this will be cancelled off by this, okay, because ar minus ar, it becomes 0. This minus by this subtracted by this, so this part also still becomes 0. We still have this and this left, just that the order is different because this time is a r to the power of n minus a, and we do the factorization r minus 1, which you get the second part. Then we have the last formula for this chapter, which is the sum to infinity. Okay, so to use this, we need to use the Sn formula. We are using this instead of r minus 1, r to the power of n minus 1, instead of using this, because in order for the sum to infinity to exist, for the values to exist, the r actually must be less than 1. Hence, it is not suitable to use this. For when n is approaching infinity, what will happen to r to the power of n when r is less than 1? And of course more than -1. So let me show you so that you have a better understanding on this. So let's say we take a value from r for r which is less than 1. Let's say for example 1 over 2 or 0.5. Okay, if you take this to the power of 2, you get 1 over 4. If you take 1 over 2 to the power of 3, you get 1 over 8. 1 over 4 is 0.25, is 0.125. And if you take this to the power of 5, let's say, it's equals to 1 over 32, which is 0.03125. You'll see that the value actually becomes smaller and smaller. So what happens when this value, the power, which is the n here, becomes big enough until it approaches infinity? This value will be, the values that we get will be very small, until we can assume it is close enough to 0, we can say that it is 0. So this is your r, this is your n. Okay, so when Rn approaches infinity, r to the power of n is also approaching 0. So what happens when Rn equals to 0? So we just substitute this inside. Okay, so you get, when s approaching infinity, we'll get 1 minus 0. And that is how we get 1 minus 0 equals to 1, so a over 1 minus r. Okay, now we look at chapter 7, coordinate geometry. So the first formula in this chapter is subtopic 7.1, divisor of a line segment, where we are looking for the coordinate of the point which divides a segment of a line by using this formula. To start off, we looked at a line which is drawn on a Cartesian plan, and we are going to plot 3 points here, A, P, and B. The point A here with the coordinate x1, y1. We have a point P which divides the line segment, and point B, x2, y2. Then if we draw a vertical line from all these 3 points, from A to the x-axis, from P to the x-axis, and B to the x-axis, we will have something which looks like this. And we are going to label this point here C, D, and E. Notice that I also note down the ratio of the length of the line segment. For AP to PB, the ratio will be M to N. this to this is proportional to the length of this to the length of this. Okay, the length of AP to PB, which can be written in the form of fraction AP to PB or AP over PB, is proportional to CD to DC. So it's proportional to CD over DE. So since they are proportional, the ratio, we can write the length of AP to PB in terms of the ratio of the number of parts here, means it is M to N. But how about CD to DE? If you want to find the length of CD here, we can refer to the X coordinate or the X value for these 3 points here. For C, the value is x1, so this is x1. D is x. E is x2. So if you want to find the length of CD, we take x minus x1 to find the length of CD. So we take x minus x1. Whereas for ED or DE, you can take x2 minus x. x2 minus x. Now we just need to rearrange this such that it matches the formula that we are trying to derive. Remember, for our formula, we are trying to find the coordinate of x. We want x to be in terms of the rest of the values. So we want x to be the subject. So that is what we want to achieve here. I try to cross multiply, so I have m, x2 minus x. Here we have n, x minus x1. And I factorize the x to get n plus m. mx2 over n plus m, which is this part. The x coordinate can be found by this. And now we want to move on to the y, where y equals to this. So this time we're still using the same diagram, just that we add a horizontal line here, and we add this point G and F at the intersection point. So likewise, the y value of this line, or this point, the y value is y1. Hence, here we have the height. It will be y1. For point F, it has a height of y. And here, of course, is y2. So we are going to do the same thing here. If we project this part of the line to the y-axis, you will see that the height here is correspond to this line here. Okay, so the height between these two is correspond to the line AP. Similarly, for this part of the graph, the height here is correspond to this. And hence, if we take the height of this, which is from here to here, the height, okay, this height and this height, they are the same thing. We are using the point P and G. So PG, the height of PG, when it is over the height of PG to the height of BF, okay, point B and point F, line BF, this is proportional to the length of the line AP over the line PB. PG, the height here, PG here can be found by taking y minus y1. Whereas for BF, the height here can be found by using y2 minus y to find the difference of the height. And AP over PB is the same as the ratio m to n, hence m over n. And we just have to find y as a subject in terms of all the other values. factorize y and let y to be the subject. So you will get this. Hence, this is how we find the coordinate of y. After that, we combine both to find this formula here. We move on. For 7.2, we are dealing with parallel lines and perpendicular lines. And there are two conjectures, one each. One is for the parallel lines where parallel lines have the same gradient. And also for perpendicular lines, when you multiply the gradient of two perpendicular lines, you always get -1. So we have now here a pair of parallel lines, L1 and L2. Hence, the gradient for line number 1 will be denoted as M1, and the gradient for L2 will be denoted as M2. Then the verification of the conjecture is based on the premise that M, the gradient of the line, is equals to tangent theta, where theta is the angle formed between the line and the x-axis. So for example, if we have theta is 30 degrees, then the gradient will be tangent 30 degrees, the value of tangent 30 degrees. So we are going to use this idea here to help us to verify the conjecture. So back to our two lines here. If we are now going to draw a horizontal line across the two lines, or we draw the x-axis across these two lines, you will have something like this. And we can use the angle formed between the line and the x-axis to find the gradient. Okay, we can use the angle formed between the lines and the x-axis to find the gradient. But since these two lines are parallel, we learned that when you draw a straight line across a parallel lines, you form this pair of angles which we call as a corresponding angles. We learned this in mathematics form 1. The pair of angles theta 1 is equals to theta 2 because this is a pair of corresponding angles. And if we take the tangent of both angles, theta 1, tangent of theta 1 equals to tangent of theta 2, this is the gradient of line 1 and this is the gradient of line 2. Hence, the conjecture is verified. So now remember when we learn in mathematics form 1, when you have a pair of parallel lines and you draw a straight line across it, this angle here and this angle here forms a pair of corresponding angles. Okay, corresponding angles. And corresponding angles, the properties for corresponding angles are that they are equal. So theta 1 equals to theta 2. If you find the tangent for both angles, you will have tangent theta 1 equals to tangent theta 2, and according to what we know, this is equals to the gradient of the line number 1, and this is equals to the gradient of line number 2, hence the conjecture is verified. Now for perpendicular lines, we have L1 perpendicular to L2, hence it is 90 degrees here. And if we now draw a x-axis across these two lines, for example like this, we will form theta 1 between the line 1 to and the x-axis, and theta 2 between the line 2 and the x-axis. Okay, so from here, we are going to start with theta 1. So we find, since we are looking at the gradient, so we find tangent of theta 1. And the triangle that we're going to use is this triangle here, and this right angle triangle. For theta 1, it is equals to the opposite side over the adjacent side. Okay, the opposite side over the adjacent side. Opposite side is AC or CA. Then the adjacent side will be BC, so it is over BC. Whereas for theta 2, tangent theta 2. So for this part, we'll learn in Form 5 mathematics and at maths, where when we deal with trigonometric ratios, this first quadrant will be quadrant 1 and quadrant 2, and theta 2 lies in the quadrant 2. And in quadrant 2, only the sine values is positive, whereas cosine values and tangent values have a negative values. The tangent of theta 2 is equals to negative, because it lies in this quadrant, of the reference angle here. And the reference angle here is used with this tangent of the reference angle. And this reference angle is actually this part here, this part. So if we take this as a reference angle, the opposite side will be BC, the adjacent side will be AC. Remember, tangent is opposite over adjacent. So opposite is BC, adjacent is AC or CA. Now we form tangent theta 2 using the length of the triangle, and we try to combine these two now. So you see, when we take tangent theta 1, this one, multiplying tangent theta 2, we are taking CA over BC, multiplying this, negative BC over CA. So BC cancelled, CA and CA cancelled, we get negative 1. And tangent of theta 1 is actually the gradient of 1, line number 1, and tangent theta 2 is the gradient of line number 2. Next, we have the third formula for this chapter, and we'll discuss this in the next video. See you!